Okay, so today's talk is going to be on managing nitrogen on organic farms. And this is such a critical topic because nitrogen is essential for plant growth. And it's essential in the way that proteins are essential for our growth. They really are that foundational building block. They are part of amino acids and proteins and nucleic acids and chlorophyll. And that's why nitrogen is a nutrient that normally produces the greatest yield response in crop plants. It promotes that rapid vegetative growth, and it gives plants that green color. It's also the most limiting for crop growth, and there are several reasons for that, and they really have to just do with the chemistry of nitrogen. And so one of the challenges with nitrogen management and organic farming is that most of the inputs into organic production are in these really complex organic forms. And so complex forms are coming from plant residue, from compost, from cover crops. And so they originated as these really complex molecules that need to be broken down by enzymes. And that's in that process, we call it mineralization, in which ammonium and nitrate become liberated from these complex molecules, and they become available to plants and to microbes, other microbes. And so the reason that it's complicated in organics is because of these complex compounds that are coming in, that these are all done by microbes. So this is a microbially mediated process. So it's very responsive to moisture and temperature. Now we're going to talk mostly about, when we talk about nitrogen, we're mostly talking about nitrate. And the reason for that is because it's the most dominant form that's found in agricultural soils. And it's the major form that's used by plants. And it's also talked about more because it's repelled by soil surfaces. And so it doesn't stay in the soil. A lot of other cations will stay in the soil. But nitrate does not, and so it moves easily. It will move wherever water moves. And so in that way, it can become an environmental contaminant, and we can also lose the nitrogen that we put into our soil that we maybe have paid for or worked towards putting there. So for all those reasons, it's an important and complicated nutrient to manage, and it's good reason to really try to learn how to master your nitrogen management on an organic farm. So today I'm going to cover this nitrogen package, and that's going to include compost, fertilizer amendments, liquid amendments, your soil organic matter, and cover crop and crop residue. So we're going to go through each of these one by one and try to sort of demystify how they're contributing to nitrogen. So we're going to revisit this figure several times. And so using data from multiple studies, we put together this conceptual figure to illustrate the nitrogen package on a farm. So let's go one by one through the bands and ignore the dotted red line for now. We'll start at the bottom with the like sort of brownish band. Sorry, the light went off. One sec. And so that one illustrates the soil organic matter in the top 24 inches. And you'll see that that band like slowly increases over the course of the summer in this example. And this is for like an irrigated field in a warm climate. And so it's basically saying that that soil organic matter is releasing nitrogen at a somewhat even level over the course of the summer. Now let's go to the next band up, the light green one that symbolizes cover crop. You'll see there's a sort of sharp increase between April and May, and that signifies like the incorporation of the cover crop in April. You see a quick release of nitrogen, and then that nitrogen is there. Next, you have the poultry manure compost. And again, that was added after the cover crop incorporation. And then you see this sort of quick release in those first several weeks. And then there's a much slower release later on. Next, you have the granular fertilizer. Similarly, you get that boost in the first few weeks. And then lastly, you have a very thin line of irrigation water, and it's slowly building because with each irrigation, you're slowly adding nitrogen. So what you can see here is that between April and June, there is just a huge amount of nitrogen sitting in your soil. Now, the dotted red line symbolizes the uptake curve. And so this was drawn for like a fresh market tomato example. You plant them in May. For that first month, a young transplant has very low nitrogen needs, and then it starts this rapid growth period. And that's what you see, this like steep incline. And then by August, you're starting to harvest, and there's really not much uptake at all during the harvest. So that's the two components that we're trying to put together in a nitrogen budget. So we'll talk about compost. Oops. Compost is achieved in a variety of manners, from vermicompost bins to aerated piles. But generally what's happening is that the most easily decomposable or mineralizable forms of carbon and nitrogen are going to be broken down. And so it reduces the mineral N content and increases the stability of it. And therefore, we'll generally be getting less from compost, less nitrogen from compost than a fertilizer. And in organic cropping systems, it's typically broadcast applied somewhere between 2 and 10 tons to the acre and incorporated usually. So one way to study mineralization are through soil incubations. And so you're going to see this figure looking at several different materials. And what we did here was we took organic field soil from commercial farms in our region, and we added these amendments, and then we monitored and measured the amount of nitrogen that was mineralized over time at optimal moisture and temperature. The temperature was 75 degrees. And so what you can see here are the nitrogen dynamics for two types of material. On the bottom, we have a composted yard trimmings. And basically, you see that it hovers right around 0. Very little to no nitrogen released from the composted yard trimmings. When we look at the composted poultry manure, we see that initially there's about maybe 15 to 18% of the total N immediately available, and then a little bit more becomes available in those first 3 to 6 weeks, and it kind of levels out after that. And so when we ask ourselves the question, how much nitrogen am I getting from my compost? Here are some good estimates. For the yard trimmings compost, it's right around 0. Sometimes it can tie up nitrogen, and sometimes it can release very small amounts. And so this is not really a nitrogen source in the short term, but it's going to be a source in the long term over years. The poultry manure compost will provide 30 to 35% of its total nitrogen in those first few weeks. And so it's pretty different in terms of nitrogen contribution from different types of compost. And the most important or meaningful way that you can predict what that difference is by knowing the C to N ratio of your material. So it's really important that you find that out from your compost supplier. Get the C to N ratio, because with the C to N ratio, it's very predictive, and that's what this curve is showing. So this is on the y-axis, you have available nitrogen over 12 weeks, and that's the percent of the total. And on the x-axis, you have the carbon to nitrogen ratio. So what you'll see is like right around here, just past 15, somewhere between 15 and 20, that line crosses 0. So whatever material you add, if it has a 15 to 20 to 1 ratio, it's hovering right at 0, and it's not going to be a nitrogen source. And whereas you go down, you get an increase. So the manure composts are these red dots, and they have like, here's around 6 to 1, here's 12 to 1. And as you all know, there's a lot of variability in compost. So if you can get that C to N ratio, that's going to be, you can then apply it onto this curve and have a good estimate. So if we take this cluster of red dots, we're getting about 30, 32, 33% of the total from that material. If you don't have the C to N ratio, you can also use nitrogen concentration. So a soil report might say, oh, it's 2% nitrogen or it's 3% nitrogen. And that's what this curve is useful for, okay? So it's not as tightly correlated, but it's still a good tool. So let's look at a soil report from a compost. So this material was part manure, part yard trimmings, and it was 2% nitrogen, 2.09%. This was reported on a dry basis, that's important, although it's 38% moisture. And here's that carbon to nitrogen ratio, 11 to 1. So first what we can do is we want to convert this to how many pounds of nitrogen per ton do I have here? So you multiply 2% by 2,000 pounds, and you get 41.8 pounds of nitrogen per ton. And in this soil report, they actually do that calculation for you. So that's the total, right? So there's a total of 42 pounds of nitrogen per ton. Let's take that to some of our figures. So we've got that. Now we have this carbon to nitrogen ratio of 11 to 1. Let's look at this curve. Okay, 11 to 1 is somewhere here. So I'm going to estimate that 15% of the total is going to become available in the short term. So I multiply 41.8 times 15, and I get 6.2 pounds of nitrogen per ton is going to be available. Now, what's my application rate? In this example, I put 10 tons to the acre. So with that amount of compost and this material, you can estimate that you're going to get around 63 pounds of nitrogen from your compost application for the crop growing that summer. So you may feel disappointed or wondering, where's the rest of that nitrogen going? Well, it's in more complex forms that will build in your soil. And so you'll be getting them later, and they become part of the soil organic matter. So here is a way to demonstrate, like visualize what that looks like. So this is continual application of the same amount of manure every year, 43 pounds of nitrogen to the acre. Okay, so in year one, we have blue. This person added this study had 43 pounds of nitrogen. And the amount nitrogen was mineralized was about 12 pounds. And so that's about a 28% of the total, 43 pounds, which is in line with what we've been talking about. So next year, how much are you getting? Well, you're going to get another 18% from year one. So just looking at the blue bar, right? So this green represents another 43 pounds of nitrogen if you're doing an annual application. So in year two, you're getting the 28% plus the 18% from year one. And then in year three, you're getting a little bit more from your first year, a little bit more from your second year, and then the most from your current year. So in that way, you can see how after about 3 years, around 4 years, you start to stabilize. There's this like steady state and this buildup in your soil of nitrogen. And this is going to be accounted for in a soil organic matter sort of release that we'll look at. So, you know, this somewhat explains part of that transition to organics, is that it takes several years to build this pool of labile carbon and nitrogen in your soil in order to make this nitrogen cycling happen. So if we revisit this figure, our compost is here in blue, and you can see how where that plays out in the rest of them. Now, the soil organic matter is here, and while that's not an action like adding compost or cover cropping, this is where the years of cover cropping and composting start to accumulate and release. And when you look at this, you can see how significant that contribution is compared to those short-term or seasonal type applications. So don't feel disappointed when you don't get all of your nitrogen from your organic inputs in year one. Your soil organic matter will be releasing that in the background and can kind of be thought of as a slow release organic fertilizer. Now let's talk about granular fertilizers. Granular fertilizers are added as a pre-plant material or a side dress. And what makes them different from compost is that they tend to have a guaranteed nutrient content. Some of them are further processed, and that makes them more available sometimes, and it can make them more uniform. They also are quite expensive. So they usually form a portion of a nitrogen budget. And these products are made of slaughter products like blood meal, bone meal, fish meal. They can be the granular meal formulations from like chicken manure or soybean or kelp meal. And then there's materials like guano. And when you look at the slaughter waste products, what's different from them is that they don't have lignin. And so they tend to be more easily available. And they're very dense in protein. So while they're high in nitrogen, they do tend to be lower in other macronutrients. And the big exception to that is going to be bone meal. So when we look at these slaughter products, you'll see this really quick spike in the first 20 days, maybe up to 40 days. And so there's none at the beginning, but very rapid mineralization. So it's very available and easily available to microbes. And so everything's going to be, everything that you're going to get is going to be available in those first, 40 days, really. And that's going to be as high as 60% of the total. And there's a lot of consistency when multiple products are compared. There's a lot of consistency for this category. Granular products. These tend to be blends of material. They are often treated to increase microbial availability. They tend to have high initial N availability and then they slow down. And some of them have some other nutrients like phosphorus and guano. And so you can look into the analysis and see what it's made of. So here we see guano differs in that it starts out with a lot of available nitrogen. Over 50% is available. And then we see this really quick release and quite a lot, over 80% of the total of the guano that you put in is available in that first year. We can look at the granular fertilizers here in orange. So you see over 20% started out, and then by the first 40 days, the first month, you can get up to a little over 40% of the total. So next we'll talk about the liquids. The liquids often are, they can be made of fish, they can be made out of plants, material, food waste. They're sometimes pre-treated to increase availability like hydrolyzed or emulsified. And so these liquid fertilizers tend to be quite available as well. They start out with some material and then they're in the over 60% available category. The plant-based liquid fertilizers tended to have a wide range of 50 to 90%. And those that were manure-based, like fish emulsion, tended to be a little bit higher, like 80 to 90% availability. The organic liquids are often in suspensions that include particulate matter. And so you want to be careful when adding these materials because they need proper filtration so they don't clog your drip emitters. And then that particulate matter, about 8 to 20% of the nitrogen is often associated with that material. So that when that is filtered, it does filter out some of the nitrogen, but you can have like a 10 to 20% designation for that. So when we put these all together, here's what the table looks like. When we look at liquid fertilizers, they have a roughly 50 to 100% availability. Remember, the manure products are a little bit higher, but the plant-based kind of have this huge range from 50 to 90. And here's the C to N ratio and the typical N. Now, we'll look at this in a minute, but the liquids don't they're not very well predicted based on the percent N, and that's because they're a liquid and the weight is off compared to the dry materials. But let's go through these now that we've talked about them. We've got our yard trimmings compost at 13 to 20 C to N, and that hovers right at 0. And as we move down the list, you'll see that the C to N drops and there's an increase in availability. So that's a really key takeaway and a simple tool that you can take to the field when you're looking at materials. So here's that curve again. And the C to N ratio does fit well for the liquids. They just don't often have that information available to you. You can get that for the fertilizers, but again, that's not always available on your label. It can be the kind of thing where you ask the company to send it to you, but it can be a little bit tricky. And that's why we also created this slide so that you can use just the percent nitrogen. And that works well for the fertilizers, but it just doesn't work well for the liquids. Here are those liquids. See, they don't follow the same pattern. So here's a summary. These, to me, are the two really critical figures that I personally reference all the time when I'm looking at materials. Because while we have these categorized, and within them we tried lots of different companies, and they do tend to fall into these categories. It's great that you can always just have the C to N ratio or the nitrogen concentration of a particular product and use that. So now I'm going to talk about cover crops. And cover crops are a great source of nitrogen, and they can contribute from anywhere from 0 to 50% of their total nitrogen can be available to the next crop. And we'll get into that a little bit. The cover crop mixes that are terminated younger, before flowering, and with a higher proportion of legumes will be on that higher side of 30 to 50%. And those that are older and have more grasses are going to be on the lower side. So here's a figure showing the nitrogen release timings from material residue that has high, medium, and low nitrogen concentration. So if you send a biomass sample from your cover crop to the lab and it says, oh, it's 3% nitrogen, then you can look at this and you see 3% right where the green and the yellow bands meet. And this is over time. So for that season anyway, you can expect about 30% of the total residue, the total nitrogen in that residue, to be available that year. So that's how you can use this, is when you send in a tissue sample and that gives you a number back. You can also use your own evaluation of the material, whether it's young or old, to estimate that. So here are some common cover crops. In this first example, I have a common vetch. Vetch is very fleshy, and it tends to make a lot of biomass. So when a common vetch is ready to be incorporated, it might be 3% nitrogen. It might have 1.5 tons of biomass. And so if we do the math there, 3 times 1.5 tons, we get 90 pounds of nitrogen is in there. And so if we take 3% and we estimate that there's about 30 or well, yeah, I have here 57% of the total nitrogen, then that would be 50 pounds of nitrogen is coming from that cover crop. And you can see how rye tends to decrease, right, compared to a fleshy vetch. This is based on what growth stage it's at. The older it is, the less nitrogen and more carbon it's going to have. And there's a lot of material available out there to give you some idea of how much nitrogen is in these different types of cover crops. So this is from some cover crop sampling that I did in Yolo County at the time of incorporation. And so I measured the biomass and the tissue content. And then this is just calculated, the tissue content times the biomass gives you the total amount of pounds of nitrogen per acre. So let's look here. These are ranked from lowest to highest tissue end content. So at the bottom, you see we've got the vetches. And then we've got the peas. Here's a cereal legume mix, where at the very top, we have the oats and the rye. So you can see that progression. So then if we do the estimation based on the tissue end content, so for those around 2.5% to 3%, I've put 15 to 30% availability. Those over 3%, I've got over 40% availability. And then when you do that calculation, you can see how much of that total N might you get this year. And you'll see it's a big difference, right? You're only going to get a smaller percent of the total. Now, what are the drivers for the N release in your cover crop? So generally, it's going to be the cover crop age and the N content. The younger the crop and the higher the N content of the species, the higher the N availability. And it's important to keep in mind that the vast majority of the nitrogen in a cover crop is in the above ground biomass. It can be confusing when nitrogen fixation occurs in the roots, but that nitrogen does not stay in the roots. It gets translocated into all that above ground biomass and growing that plant material. So the nitrogen is not in the roots. There's a very, very small percent, a negligible amount in the roots. It's really about the above ground biomass for legumes and for cereal crops and all these crops. Now, we often think about cover crops as a soil fertility tool because we're growing crop debris that we're putting back into the soil. And it's either creating nitrogen from the atmosphere when you have legumes, or it's capturing residual soil nitrogen and putting it into the biomass that gets incorporated. But it's not to overlook that a previous crop can also be doing that. And so even if you're following a crop with a crop and not a cover crop, there still is nitrogen coming from that previous crop that can be accounted for. And in some cases, that can be very significant. So this table here shows what some of those estimates are. And let's look at broccoli. For those of you who have grown broccoli, you know that you only harvest a pretty small amount of all that biomass that gets produced. So in a broccoli crop, it's expected that you have about 180 to 260 pounds of nitrogen per acre from just the crop residue. So that's a major contribution to the following crop. So here's that table again. And now we can add our cover crops, adding about 0 to 50% for that subsequent crop. And next we'll talk about soil organic matter. And that's our last material to talk about. So the soil organic matter is one of my favorite ones to talk about because it's kind of like the silent source. As you've seen, oftentimes most of the nitrogen that's added is not actually available. And so it's building this robust engine of soil organic matter that becomes this major source. And so a common rule of thumb is that during a summer growing season, about 1 to 3% of the total soil N becomes available. And so that's somewhere between 50 to 120 pounds of nitrogen in those top 12 inches. So here's a curve showing soil organic matter release in 2 different regions. So Yolo County, this is like a hot inland county. Salinas is the coast. So let's just look at the top figure first. And on the x-axis, we have time, so January to December, and that's really reflecting the temperature, because that's a big driver for these microbial processes. And on the y-axis, we have the nitrogen release rate. So, and then we have 2 different soil organic matter percents. The black line is 1.5%, and the green line is a 3% soil. So they each have different amounts of nitrogen potential. So if we look at the green line on top, we can see in January when it's cold, there's some release, but it's small. And then as it warms up, we have this great spike. And then as it gets really hot and then begins to cool down, it goes back down again. And so as you can see, in those warm months, that can be a really significant contribution. Now we see a similar curve on the coast. It's just not as pronounced of a peak because it's just not as hot. And so it's just generally lower on in the coast than in the valley. And here's a table to actually calculate how many pounds of nitrogen are released per month. So you could add up the months that you're growing and get an estimate of how much nitrogen you might be getting from your soil organic matter. So we've talked a lot about the building of the soil organic matter through all of these practices: compost, cover crops, fertilizers. And if you remember that figure I had where we had the annual compost application, and every year, you know, the first year you get the most, but you still get some every year. And what this is showing is a similar concept. And so this is the age of the residue. 2 years old, 4 years old, 6 years old. And this is the percent of the residue left. And so you can see that same concept where you have a sort of decrease over those first 4 years. And after that point, it becomes these old, really recalcitrant, slow to break down material. So in the soil organic matter, we're really talking about these active pools of nitrogen. And what's contributing to these really active pools are the crop residue, the manure, the compost, the cover crop. And they remain labile for those first few years. So now let's sort of step back a little bit and think about all these materials and what affects their availability. We're going to talk about the chemistry, the temperature, and the placement. So the fertilizer quality, we've talked pretty well about this. The C to N ratio, the percent N, the complexity of the materials, and the amount of the mineral N initially. So these 2 figures are great for understanding the fertilizer quality. Now looking at temperature, how much of a factor is temperature? So here are 3 figures showing that. And each of these different lines, which I understand it's probably a little bit hard to see, they represent from 50 degrees Fahrenheit to 77 in that middle one, or 40 to 77 in the top one. And what you basically see is there's a little bit of a delay and a little bit less nitrogen availability from lower temperatures. So you get about a 1 to 3 week delay. and the total is 10 to 15% lower. So you can use that to think about how I've mostly been talking about the summer, but you know, depending on where you're located or what season, or if you're in a fall or spring season, you can use this to help make some of those adjustments. Placement. Sometimes material is added and not incorporated. It's placed on top of the soil. So how much of a factor is that in your availability? So this was a trial done by Richard Smith, in which he placed material, fertilizers, into these bags and either buried it in the soil or placed it on top of the soil and measured their availability. So this is days after planting, and on the vertical axis we have the percent mineralized, and the black represents the material that was buried. And so you can see this really clear difference between higher mineralization of the material that was buried. This was a 442 granular type fertilizer, organic fertilizer. So in this case, he was getting in the 60% mineralization when the material was buried, as opposed to as high as 50 in the material that was left on the surface. And the reason for this has to do with contact with microbes and moisture. And as we all know, it's the microbes driving these processes. So leaving it on the surface is affecting the microbial ability to access the material and for the material to stay moist to support microbial activity. So in summary, we have that first piece of the C to N ratio and the percent N. We've got temperature, the role of temperature. We can reduce it by 10 to 15% in cold weather, especially for really complex materials. And then we've got placement, which can reduce mineralization by 30 to 50% when it's surface applied. And you also want to be thinking about, is the soil surface moist or dry? You know, you can add in your own factors to really identify where on that 30 to 50 you might be falling. So it's really great to be able to check how you're doing and how you're estimating. And the best way to do that is through soil testing. And you can use soil tests for in a few different ways. It can provide a guide to how much is needed at a given time. So it's critical to realize that soil tests only tell you about what's happening right now. And then your soil test can also be used for monitoring. You know, you can look at the end of the season to see, well, how much residual N did I over-fertilize? Do I need to capture some of that N by planting something right away, et cetera. And then if you add amendments, you might want to check, are they actually becoming available at the anticipated rate? Okay, and as I said, it only tells you about what's right now. So you can't use a soil test that was taken in February for your April planting. It's going to be, it could be significantly different. So it's a great practice to be taking a soil test right before this rapid growth period of your crop, because that's when you really need to have enough nitrogen, or else the nitrogen is going to limit your crop's ability to achieve optimal yield. So these curves are available for most crops. So get this curve, know what your curve looks like, and check right before its high growth period. And what is often the case in organics is that you are front loaded. And so it's usually not a concern because you've cover cropped, you've added your compost, you've added your fertilizers. And so you usually have high amounts of nitrogen when you really have no crop demand yet. And that's actually the tricky part of organic nitrogen management, because we have all this nitrate sitting in the soil ready for use and nothing to use it. And so if we start irrigating that nitrate's going to move with the irrigation water. And so like a big sprinkler irrigation to get a transplant established, we could be moving that nitrate farther down to the soil profile and making it difficult for those roots to access that nitrogen. So be thinking about how you're doing that early watering during plant establishment, because you want to be keeping that nitrogen in the top 12, maybe 24 inches for that rapid growth period. So here's another way to look at the timing of fertility. So this is the same data that we were just looking at, but it's on a pounds of nitrogen per day release. And so what you can see is all the same colors represent the same thing. So we see this huge quick release on a day-to-day basis early on. And this one spike we're going to focus on, this is your granular fertilizer. Okay, this is like your 442 or your guano or something like that, that you put in a small amount, but it has high M. And so it's available pretty quickly. So that's what it looks like pre-plant. So what this shows is, let's see what that looks like as we move it over for like a side dress, or if we run a liquid application. And so that's what you can do with your daily nitrogen availability by moving, by choosing side dress or a liquid run during the season. So in summary, really get to know the C to N ratio of your material. That's the decisive factor for nitrogen, for estimating nitrogen release from organic material. And remember that 15:1 is that threshold of nitrogen tie-up. High mineral nitrogen content usually leads to good short-term N availability. Lower availability estimates for cooler temperature and surface application, and use soil tests to check your expectations. And be really careful about your early season irrigation when you've got the soil loaded with all of your nitrogen, but your crops are just not quite ready for it. So all of this is available in this is a academic paper, but we also have it available in an Excel document that you can use that's interactive, and we also have a sort of grower resource document that you can use to basically read and have a guide for everything I just talked about. And this was really a group effort. This is numerous studies, and all of these collaborators who have been working on nitrogen management for many years. Daniel Geisler at UC Davis, Patricia Lizicki, Richard Smith, a farm advisor on the coast, Joji Muramoto, who's our specialist on the coast as well. So that's the gist of my presentation, and I hope that you learned a lot. Let's see, how are we doing on timing? I have about 20 minutes left, 25 minutes left.
We have about, 28 minutes left. We end at 1:15.
Okay. So I'm going to go through one exercise to sort of show how this is done, and then I'll just take some questions. So I wanted to kind of present like a little case study of how you might use this. And so let's take a situation where we've got fresh market tomato grown in the summertime, and this farm, they add compost and fertilizer right before planting. And over the course of the season, they run a liquid fertilizer 3 to 5 times during that rapid growth phase. They take a soil sample one time a year, they cover crop right before this May planting of tomatoes, and the soil organic matter is 3%. Maybe that sounds like a typical thing that you might do. So the first part of this is to Identify how much nitrogen you need. And if you've never really gotten a good sense of that, there's some really good resources, and I can drop them in the chat, for how to get an estimate of that. And for a lot of our common crops like tomato, you can do it based on yield. So if you know your yield, you can calculate your nitrogen content based on that. Or you can do it based on looking at the average uptake for a crop. So get your goal established. And so for the tomato, I chose 240 pounds of nitrogen was my goal. Now, we'll walk through this very slowly. So let's start at the top, and you can follow what I've written in red. That's basically me filling out this worksheet. So I've chosen a yard trimming space compost, and the C/N ratio of that compost is 15:1. And the report that they gave me told me it was 15:1, and it also told me that it was 35% water and that it was 1% nitrogen. So there's an important caveat here to clarify with your compost supplier, whether they're delivering you compost on a as-is weight or a dry weight, because it can be kind of significant. So I did this one with a as-is, just to make the point of making that adjustment. So, if you order 10 tons of compost and they give you that as is, and your compost sits on the farm and it dries out, it still is that initial 10 tons. And so you want to account for that when you're actually trying to figure out how much nitrogen is there. So you make that adjustment, the 20,000 pounds of nitrogen per acre, adjusted for 35% moisture, and you're left with 13,000 pounds. Now we're going to use that 1% to get the total nitrogen in it. So 1% times 13,000 pounds is 130 pounds of nitrogen per acre. And then we go to that very last calculation. Well, how much of that am I going to get? And that's where you look on that nitrogen curve to see, well, where does 15:1 fall? Well, it falls just above 0, so I'm going to put 2%. So of that 130 pounds, I'm going to get 2% of that. And so that's about 2.6 pounds of nitrogen from that material. So in this way, you can start to do these estimations of how much nitrogen you're getting from these materials. And I'm going to drop in the chat this link. And at that link, you'll find a document that can guide you through this whole process. Actually, I'll share my screen maybe one more time and show that document with you. Here. Okay, so this is where that link will take you. And this is all the material for a nitrogen workshop we gave. And if you click on this nitrogen estimation worksheet, that's an interactive Excel document where you could put in, oh, my fertilizer was 9% nitrogen, and it's a guano, and it can help you do those calculations. And then if you click on the PDF document, that's where it's an interactive guide, and it will walk you through. And as part of that, it has a demo. And so this is like the one I just did with you guys. And it will go through this exercise for the cover crop, for the liquid, for the fertilizers. So you can sort of test yourself and also remind yourself how it might be done. So I hope you find this page useful. And if you want full presentations on these different topics for soil organic matter, cover crop, nitrogen, you can also find them here. Okay, so I welcome any questions that you might have.